So, the primary bile acids are the cholic acid and chenodeoxycholic acid, which are synthesized in the liver, and immediately after their synthesis, they will be undergoing conjugation with glycine and taurine to give glycocholic acid, taurocholic acid, or glycokenodeoxycholic acid and taurochenodeoxycholic acid. The basic difference between cholic acid and chenodeoxycholic acid is that cholic acid is having an OH group on the 12th position. That is, cholic acid is having a total of 3 OH groups, one on the 3rd position, one on the 7th position, and the third one on the 12th position. While chenodeoxycholic acid will be having only 2 OH groups, one on the 3rd position and the other on the 7th position. Okay, so that's a basic difference between cholic. That's the difference between cholic and chenodeoxycholic acid. So as soon as they are formed, they will be undergoing conjugation with glycine and taurine to give glycocholate and taurocholate. And also again, before getting secreted into the bile, they will be converted to the sodium or the potassium salts of glycocholic and taurocholate. So sodium taurocholate. Potassium glycocholate, etc. And these salts are then secreted into the bile. Okay, and this is how and they are stored in the gallbladder. And whenever their demand arises, what happens? They will be released into the intestine. They will be secreted into the intestine. And on reaching the lower part of the small intestine, what happens? They will be subjected for bacterial action. Intestinal bacteria acts upon these bile acids, so that from these bile acids, these primary bile acids will be converted to the secondary bile acids. So what's the change happening there? They undergoes deoxygenation, right? So the intestinal bacteria, they will be first carrying out the deconjugation reaction. The glycine, the taurine molecule will be removed, and this is followed by the removal of the OH group on the 7th position. We know that both cholic and chenodeoxycholic acids are having OH group on the 7th position. So after the deconjugation reaction, the OH group which is added on the primary bile acids will be removed to give rise to deoxycholic acid. If cholic acid is converted into secondary bile acids, the resulting product will be called as deoxycholic acid. So how does deoxygenation happens? First, the glycine and the taurine will be removed, and this is followed by the removal of the OH group on the 7th position. So they are known as deoxycholic acid. And chenodeoxycholic acid. Deoxycholic acid and chenodeoxycholic acid, or chenodeoxycholic acid is otherwise known as lithocholic acid. So these are the secondary bile acids. So the secondary bile acids are synthesized in the lower part of the small intestine, while the primary bile acids are synthesized in the hepatocytes. So the primary bile acids are synthesis is carried out by the enzymes in the hepatocytes, while the secondary bile acids are synthesized by the action of bacteria, by the intestinal bacteria. So the intestinal bacteria converts the primary bile acids into the secondary bile acids. And so this is a cholic acid. See, it's having the OH groups. The double bond is also removed. There is no double bonds. That's another action. That is NADPH is coming, right? So the NADPH will be converted into NADP molecules, right? So this NADPH will be carrying out the desaturation, or the double bonds are removed on the 5th and the 6th carbon atom, and it is becoming a saturated carbon atom, right? So this is the structure of cholic acid. Cholic acid undergoes oxidation, right? Not oxidation, sorry, it is undergoing reduction by introducing the hydrogen atoms by the removal of the double bonds in cholic acid, and also the chenodeoxycholic acid, right? So this is the structure, right? So this is a structure of cholesterol, but with a reduced number of carbon atoms. See, this is cholic acid. So once the propionic acid is formed, it is CO double bond CO is COA iron, and it's finally converted into cholic acid. The CoASH will be removed. Cholic acid will be formed. Then to this cholic acid, to this COOH group, what it is undergoing conjugation with glycine, right? And this glycine then converts it into sodium salt of primary bile acids, or potassium salts of primary bile acids, known as sodium glycocolate or sodium taurocolate. Similarly, sodium glycokenodeoxycolate and potassium taurochenodeoxycolate, etc. So these are the primary bile acids. So this is a structure of colic acid with three hydroxyl groups, one on the third, the seventh, or second on the seventh, and the third on the 12th position, with the double bond will also removed, and also the three carbon atoms are removed in the form of propionyl CoA. And this is chenodeoxycholic acid. See, the 12th hydroxyl group is not present. So that is the chenodeoxycholic acid. Okay. So glycolic acid, taurocholic acid, glycokenodeoxy, they are the primary bile acids. They will be undergoing salt formation with sodium and potassium. And this is, they are known as the bile salts. So bile acids, when undergo reaction with sodium or potassium, then they are known as bile salts. They are formed in the liver and are excreted through the bile into the intestine. And the bile salts thus entering into the intestine, 98% majority of the bile salts thus entering into the intestine will be reabsorbed back into the liver through the portal bed. So this is known as enterohepatic circulation. That is the circulation of blood between the intestine and the liver, carrying the bile salts. So 98%, most of the bile salts and bile acids thus entering into the intestine will be returned back to the liver through the portal circulation, and they are excreted again, they are secreted into the intestine by the liver. So this process is always continued. So this is known as the enterohepatic circulation of bile salts. So intestinal bacteria converts the unabsorbed bile salts into the secondary bile acids and sterols. That is, the 98% of them will be entering into enterohepatic circulation. So the remaining 2% will be acted upon by the small intestinal bacteria, so that the primary bile acids are converted into secondary bile acids. That is the deoxycholic acid and lithocholic acid. Lithocholic acid means deoxycholic acid. They are the secondary bile acids, and they are excreted through feces. Right. So the coprostanol is main sterol formed from the bile salt. This is a sterol that is synthesized from the bile salts, and they are excreted in the feces. So we can isolate the coprostanol from the feces. So if there is any block in this transportation, it results into the accumulation of this bile. So resulting in the formation of lithiasis. This is known as stone formation. They are known as cholelithiasis. So the accumulation of bile salts and bile acids, phospholipids, etc. in the insoluble form. They are responsible. They are responsible for keeping the cholesterol in the bile in the soluble form. That's a function of bile salts and phospholipids. But if there is a deficiency of this bile salts, what happens? They start accumulating. This cholesterol start accumulating in the gallbladder, and this condition is known as cholelithiasis. Right. So due to the deficiency of the bile salts, what happens? The soluble form of the cholesterol will become insoluble, resulting in the formation of stones. So there are stones, right? Yellow colored pigment. So these are the cholesterol stones which are accumulated in the bile gallbladder, and the condition is known as cholelithiasis. Patients with this condition respond to administration of the bile acid, chenodeoxycholic acid, known as chenodiol. So in those patients having cholelithiasis, what is the drug is given for making, that is, bile acids are artificially administered so that cholesterol is made soluble, and this drug is known as chenodiol. And surgical removal of the gallbladder is the only remedy. So this is the enterohepatic circulation. That is the circulation happening between the liver and the intestine. So the primary bile salts, they becomes primary bile acids. Primary bile acids will be, that is, first primary bile salts will be undergoing deconjugation, followed by the attack of the small intestinal bacteria, so that secondary bile acids will be formed. And the secondary bile acids, the bile salts, glycine, taurine, etc. So what is happening? The majority portion will be entering into the portal circulation, and they are entering back into the liver. So the secondary bile acids, the primary and the secondary bile salts, etc. will be formed. They will be again converted into the primary bile acids. Again, cholesterol also will be formed. So the liver is continuously, since it's around 500 milligrams of cholesterol is synthesizing, right? And again, cholesterol bile acids will be again bringing the cholesterol back to the liver through enterohepatic circulation and all, right? So this is how the circulation happening. And what happens is primary bile acids again entering into liver, again enters back into the portal circulation, they are again entering back into the intestine, and this pathway continues in a cyclic process, and this is known as what? Enterohepatic circulation. That is the shuttle between, or the transport of bile acids and bile salts from the intestine to the liver and back from the liver to the intestine in a continuous manner is known as enterohepatic circulation. So these are the structures of different bile salts. Deoxy secondary, these are the bile acids, secondary bile acids. Deoxy, see, deox, there is no OH on the 7th position. So it's deoxycholic acid, and here there is no OH group. Again, also it's chenodeoxycholic acid. So the chenodeoxycholic acid is undergoing the removal of the hydroxyl group from the 7th position. So give rise to lithocholic acid, and this is the artificial this undergoes modification. This secondary bile acids now undergoes modification by the intestinal bacteria, so that this coprostanol is formed. This coprostanol is the secretory or excretory form of bile in the feces. Okay, so there is no COH. Again, the 27 carbon is again retained. And what happens when this cholesterol, if there is any imbalance in the cholesterol metabolism, there is the accumulation of lipids and atherosclerosis. We know that the cholesterol is transported in the form of LDL, HDL, etc., and small portion by VLDL and TG. VLDL and chylomicrons, right? So the transportation is carried out by lipoproteins. So if there is an accumulation, if there is an excess quantities of cholesterol, what happens? They get accumulated along the walls of the blood vessels and finally lead to a condition known as atherosclerosis. So it's a condition in which the cholesterol and other substances, lipid soluble substances, are deposited in the walls of the blood vessels, resulting in the narrowing of the blood vessels, thereby impeding or thereby blocking the smooth flow of blood. So that the organ will be the target organ will be having a shortage of oxygen and blood supply. So this is a normal blood artery, and slowly the cholesterol and the lipid soluble substances get accumulated due to increased levels in the body. So the plaque formation happens, and they impede the supply of blood to the corresponding organ, see, resulting in the death of that particular tissue. So this is known as atherosclerosis. And the most affected arteries are the coronary arteries, and the condition is known as coronary artery disease. And other organs are also affected. If the supply of the blood is blocked in the brain, it leads to stroke, right? So that is a condition related to cholesterol metabolism. And there are which are the risk factors for CAD, risk of CAD. There are various, of course, we know that's our dietary habits, our lifestyle, etc. All of them can increase the risk of incidence of coronary artery disease. And these are the various risk factors. Dyslipidemia, that is, the metabolism is not happening in the proper manner. High blood pressure, diabetes, obesity, smoking, lack of physical activity, unhealthy diet, and stress. Then cholesterol is present in plasma mainly in the form of LDL and HDL. If there is an elevated LDL value, there is an increased risk for coronary artery disease, because LDL transports cholesterol from the liver to the peripheral tissue. Okay, so high HDL has a protective effect. So these are the various normal values of various lipoproteins. So total cholesterol is desirable is less than 200, borderline is 200 to 239, high risk greater than or equal to 240. These are the total cholesterol values. HDL cholesterol greater than 60 is a desirable value in case of females, greater than 50 in case of males, and case of borderline 50 to 60, 40 to 15 males. High risk less than 50 and 40 in males and females and males respectively. Now LDL cholesterol should be always less than 100 milligram percentage, while TG should be less than 150 milligram percentage. Borderline is 100 to 159, 150 to 199, greater than 160, greater than 200. All of these, if the value is exceeding the borderline, it can have an increased incidence for coronary artery disease. Now, ApoA1 and ApoB are also giving informative values on the CAD. That is, a rise in ApoB level indicates an increased risk of CAD, ApoB 100. LDL apoprotein. So ApoB 100 value there is an increased risk of coronary artery disease. Similarly, a rise in ApoA1 indicates a risk, reduced risk. When we are discussing on the apoproteins, we have told that ApoA1 is an anti-atherogenic apoprotein, because ApoA1 is HDL, belong to the HDL. So increased A1 leads to reduced risk.